Guys, in this video we are going to see how to solve an exact differential equation. Now to solve an exact differential equations, first of all we had to know the pattern of this equation. So for an exact differential equation, the equation going to look like this: m of xy dx n of xy dy is equal to 0. Or you may see other method like other way, like m of xy plus n of xy y prime. So it's going to be in both ways. So here the main thing is we have to identify m of xy and n of xy. And if you look at this equation, whatever the value combined with this dx is going to be our m of xy, right? So this is our m of xy. And whatever the value that is combined with dy is going to be n of xy. So this is our n of xy, right? Now let's go ahead and write that one down. M of xy is equal to this one, cos x sin x minus xy square, and n of xy is going to be equal to y times 1 minus x square. Now we have m of xy and n of xy, and the next step is we have to find out whether it is exact. To find whether it is exact, we take the m and find the derivative with respect to y, and also we take the n and find the derivative with respect to x, and we see whether it is giving the same answer. If it's giving the same answer, it is exact. Now let's go ahead and find the derivative of this one with respect to y. So my is going to be, so we if we take the derivative with respect to y, we treat x as a constant. So this thing, these two are going to be, cos x sin x is going to be constant, right? And if you take the derivative, that's going to be 0. So this is going to be 0, and here we have y square, and derivative of y square is going to be 2y. Since we have negative, this is going to be negative 2xy. And let's go ahead and find the derivative of this one with respect to x. So here we treat y as a constant, and inside the bracket we have 1 minus x square, and the derivative of this one is going to be minus 2x, and y is, we treat y as a constant, so this is going to be minus 2xy. Since we are getting the same answers, this is an exact differential equation. Now we have found out this is exact. After that, what we have to do is we have to use this equation. Now first of all, we have to decide which one is integrated, which one to integrate. We can integrate this one or this one, but which one is easier to integrate? This is definitely easier, right? So let's take this one. So this is our nxy. So we know that nxy is equal to, n of xy is equal to partial derivative of f respect to y. So we write this one down right here. Partial derivative of f respect to y is equal to n of xy. And the next step is we have to integrate this one respect to y and see whatever what's the value we are getting. That's going to be our f of xy. So after we find out f of xy, we have to equate this one to c, then that's going to be the final solution. And let's see what we get. If we integrate n of xy, that is y times 1 minus x square dy, and if you integrate this one respect to y, this is going to be y square divided by 2 times 1 minus x square. So now we have taken care of the y part, and for the x part, what we do is finally we write h of x. Now we have to find the h of x value in order to write this in this format. So to find h of x value, what we do is, now we have find this one, and we have to go to the next one. We have dealt with the partial derivative of f respect to y, and partial derivative of f respect to x is m of xy, and that's going to be equivalent to the derivative of this one respect to x. So before we integrated this one with respect to y, now we have to find the derivative of whatever the solution we have. This is f of xy, and we have to find the derivative of this one respect to x, and we treat y as a constant. This is going to be just y square divided by 2 times minus 2xy So minus 2 cancels, so we are going to have minus x y square, right? And also this is going to be h prime x, and that is equal to this one. And let's say this is g of x, or yeah, so let's say this is this one, and the next step is we have to integrate this one because we have to find this h prime x. And also this is equal to this one, right? So this is equal to m of xy, and we know that m of xy is equal to cos x sin x minus xy square, so we can equate that one right here. Cos x sin x minus xy square, and we have this one right here. And if you notice, we have minus xy square minus xy square, and whatever the term, like plus this one, and here we have this one, so this one must be equal to this one, right? Because this one same, so this one h prime of x must be equal to cos x sin x, but we need this one because our final solution should be this one, f of xy plus equal to c. So we have to find this term in order to write it in this way. Now we have h prime of x, so to find h of x, what we do is we integrate both sides. So if you integrate h prime of x, and this is going to be integration of cos x sin x in terms of x dx, right? So dx, and this is going to be h of x is equal to, okay, here we have to use u substitution. So let's continue this one right here, right? So here we have to use u substitution. Let's pick u as sin theta, sin x, and du is going to be cos x, right? So this is going to be cos x, so we cos x dx, actually cos x dx, and then we are going to have integration of u du. So the answer is going to be u square divided by 2 plus constant, but here we can neglect the constant because finally we are going to equate everything to constant, so we can combine whatever the constant it is, right? So here we are going to have u square over 2, and we know that u is equal to sin x, so we can write this one as sin square x divided by 2, and that's going to be our integration. So that is equal to h of x. H of x is equal to sin square x divided by 2. Now we can go ahead and write our final answer. So this value f of xy is going to be, we know that y square over 2 times 1 minus x square plus h of x. Now we found out the h of x in terms of this, that is sin square x over 2. Now we can replace this one. So the new equation is going to be y square divided by 2 1 minus x square plus sin square x divided by 2 is equal to constant. And to write this one in better way, you can say, let's say 2c is equal to c1, right? So if we write this one, we can write this one as y square times 1 minus x square, because we are multiplying 2 by both sides, so this is going to be y square times 1 minus x square plus sin square x is equal to c1, because c1 is equal to 2c, so we can rewrite the final answer as this. So this is going to be our general solution of this differential equation, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.